If you y1, y2 it, you could see what you should be getting, and then you could check and see if you did get what you should be getting, and boom, you're happy or you're not. Okay. So there are 3 methods for solving exponentials. First one, you check for common base. Can I get common base between 4 and 3? No. Second one, I say, is there one exponent? No. So I have to do the third type, which is not optional, right? At this point, I check if I can do the first 2. If I can't, I have to do the third, which is log base 10 both sides. So we're going to go log base 10 of 4 to the 2x minus 1 equals log base 10 of 3 to the x plus 1. Drop it in front, so we get 2x minus 1 log base 10 of 4 equals x plus 1 log base 10 of 3. Then we distribute, so we get 2x log base 10 of 4 minus 1 log base 10 of 4 equals x log base 10 of 3 plus 1 log base 10 of 3. Then we can get our x's to one side, so we get 2x log base 10 of 4 minus x log base 10 of 3 equals log base 10 of 3 plus log base 10 of 4. Take an x out, and we're left with 2 log base 10 of 4 minus log base 10 of 3 equals log base 10 of 3 plus log base 10 of 4. Divide 2 log base 10 of 4 minus log base 10 of 3. And remember, we can just put this in our calculators as just the log. We don't have to put base 10, correct? And what do you get to 2 decimal places? X equals?
1.48.
148. Number 2, it says solve. It's an exponential. I have 3 types I can do. You have to do this every single time. See, solve, exponential, when there's a variable and an exponent. Type 1, common base. No, currently not. Type 2, 1 exponent. Yes, so it's 1 exponent I can convert to a log if I have 3 pieces of information. Currently I have 4 pieces of information. So what am I going to have to do? Divide the 2 over. And I rewrite the question. I don't work out of the question. So I'm divide by 2. 4 to the x plus 1 equals 3. Then I can convert. Base my exponent becomes base my log. So I get log base 4, and then 3 goes beside it, equals x plus 1, subtract 1. Log base 4 of 3 minus 1 equals x. What is x equal to 2 decimal places? What did you get?
0.21.
We agree? Once again, it says solve. So could I not have went y1, y2, got the answer, and it should match? Walk away knowing I'm happy or sad, right? Those are the 2 options. All right. 3. This equation can be written as what? Single logs can be converted to exponential. Single logs can be converted to exponential, correct? Today we're going to get more than 1 log. And then you're not going to be able to convert to exponential. You're going to have to do it a different way. So remember, exponentials has 3 types. Solving logs has 2. When you have a single log, you do it this way. Actually, it's 3. Single log, do it this way, or double log, you can have 2 options. Okay. So I'm going to have 3 pieces. 1, 2, 3. I have 3 pieces. So that means I can convert to exponential. The base of my log becomes the base of my exponent. So I get x plus 1 to the 2 equals y plus 1. And then they're in y form, right? So I'm just subtract 1 from it. And I get y equals x plus 1 squared minus 1. B. C, the equation 2 times 5 to the x plus 2 equals 7. 1 exponent can't make common base, must convert to a log, correct? However, right now I have how many pieces of information? 4, and I need to only have 3. So I'm going to just divide the 2 over again. So I get 5 to the x plus 2 equals 7 over 2. And then I can convert to a log. log. The base of my exponent becomes base of my log. 5 of 7 over 2 equals x plus 2. And then I can subtract 2. X equals log base 5 of 7 over 2 minus 2. And that is C. Then we're going to flip over. This one is like yesterday's. So if I have log base 3 of 5, I can fill in 3y. If I have log base 3 of 4, I can fill in 2x. If I have log base 3 of m squared, I can fill in a 6. I have log base 3 of none of those. But can I make that be those? 100 is 5 times 5 times 4, correct? So I can go log base 3 of 5 times 5 times 4. And then I need m4s to be m squareds. How many of those do I get? 1m squared? 2m squareds. Now do I have all the forms I need? 5, 5, 4, m? Yep. What can I do in multiplication? Add a whole bunch of logs. So I'm going to get equals log base 3 of 5 plus log base 3 of 5 plus log base 3 of 4 plus log base 3 of m squared plus log base 3 of m squared. And so I'm going to get log base 3 of 5, which is 3y, plus 3y. Log base 3 of 4 I can toss out and replace with 2x. And then m squared, log base 3 of m squared I can replace with 6 and 6. So I'm going to get 3y plus 3y, which is 6y, plus 2x, plus 12. Number 6, these are all single logarithms. So 5 and 6 are done the most poorly on every test and diploma I ever see because you guys forget about them. Okay? But we keep repeating them, so hopefully they stay. So I'd star 5 and I'd star 6. So 6. The problem with 6 is that it's not all logs, but they write it all as a log. So that confuses people, right? I need them all to be log base A, log base A, log base A. So I can put them together. And what else do I need in front of them? Plus or minus 1s. Exactly. So I have log base A of B plus, I can take this 4 and drop it up here. Log base A of AC to the 4 is just A to the 4, C to the 4 minus, now how the heck can I write 4 as log base A? Log A to the 4, correct? Because if I have A to the anything, the answer is that something, right? The exponent is the answer. So if I need log base A, I just go A again, and then anything I put up here in this exponent will be the answer. So I need 4. We agree? So what's beside my log A? An A to the 4. So now I'm going to get, I have plus or minus 1s in front of everything. So log A, B is going to go in the numerator, because there's a plus 1 in front. A4, C4 is going to go in the numerator. Maybe like R2, D2. And then this one is minus 1 in front. So A4 is going to go to the denominator. My A4s are going to cancel, and it's going to match C. Okay, 7 says, given this, and log a y equals x, where a is greater than 1, the value of x is what? I don't know. I do see here something. I see that this is base A and this is base A, so how can I put them together? When you have base A's, same base, and you divide, you just subtract them. Exactly. So we're going to go y equals a to the x over a to the 2x minus 6 is a to the x, and then we have to subtract. So I'm going to minus the 2x, and I'm going to minus the negative 6, which is actually plus 6. So I have y equals a to the negative x plus 6. Do we agree? So I know what y equals. So can't I just put it in for y? I can swap out the y's, can't I? And now I know what y equals. Take that y, toss it out, and replace it with a to the x to the negative 6. So I have log base a of y equals x. But I can replace the y with log base a of a to the negative x plus 6 equals x. We just went over this. If I have log a to the something, what's my answer just? Yeah, just the something, just the exponent, right? When these are the same numbers, so if it was log 4 to the something, my answer would be the something. Log smiley face to the smiley face to the something, my exponent would be the answer. So if I have log a to this, I'm going to actually just have negative x plus 6 equals x. And then I can just solve. So I'm going to get 6 equals 2x, 5 by 2, x equals 3. That's it, right? Yeah. Okay, I'm going to get you guys to go open up some paper to where your notes would be, and we're going to do some solving of logs that are not single log. Solve logs that are not single log. So yesterday we had a title, Solving Exponential, and I had type 1, common base. Then I had type 2, single exponent. Then I had type 3, can't make common base, not a single exponent, had to log base 10. There was the 3 types when it said solve and it was exponential. We agree? There's going to be 3 types to solve if it's a log as well. We already did 1. So we're going to do solving logarithms. Type 1. So we're going to do single logarithm. So when you look at the question, it has one log. Not numerous logs, just one word log, right? So say I give you solve 2 log base 6 x plus 1 equals 4. You try and solve it. So if I have a single logarithm, I'm going to convert to exponential. So I need to have 3 pieces of information if I convert from exponential to log or log to exponential. We agree? Right now I have 4. So I'm going to have to divide the 2. Now what they can also do is they could take the 2 and they could raise it up here as well, actually. So if they don't go even, they can take the 2 and bring it up as the exponent, or they can take the 2 and divide it. And the only reason why we can bring it up as the exponent, because there's a log, right? I'm in divide by 2 because it works out so nice. Wow, that is, why did I pick that? So we're going to get log base 6 of x plus 1 equals 2. Then I convert. The base of my log becomes the base of my exponent. What's with it doesn't stay with it because it's not friends. So the 2 becomes my exponent, or else this is not a base. And equals x plus 1. Subtract 1. X equals 35. Now, I could y1, y2 the original, correct? But my x max needs to be bigger than 35, or it's going to tell me, it's just going to get mad at me. My calculator will get mad at me. Because if your x max isn't bigger than the answer, it can't find it. Okay? Type 1, we've done. Type 2. All logarithms. So more than 1. Every term is a logarithm. Log, log, log. On each side. Every single term on all the sides of the equal signs are all logs. So, what does that look like? Solve. We'll do an easy one first. Log base 6 of 2x minus 1 equals log. The moment I write a second log, I can't do 1. Right? The moment I write second log, type 1's out. Log base 6 of 11. This is the easiest one out of all of them. So, type 2, you have to have more than one log, and every term is a log. So what does that mean? I have a log something equals log something. I don't have like a plus 6 somewhere randomly sitting in there. Every term has a log. Starts with log. Okay? If this happens and you have a log on one side and a log on another, we're going to do the next one where it isn't as easy as this. But if I have log base 6 of something equals log base 6 of something, what can I then say? Those are equal. Just like, when we had 2 to the something equal 2 to the something, I could say that the exponents must be equal. If I have log base 6 of something equals log base 6 of the other something, then those must equal, or that's not a true statement. So I'm going to have 2x minus 1 equals 11. Add 1. 2x equals 12. Divide by 2. X equals 6. Now you always have to check to see, whenever you have logarithms, you have to check to see if your answer works or if it's extraneous. Why is that? Because you cannot have a negative or a 0 beside a log. So when you plug your solution back in, if it gives you a negative beside a log, it's actually extraneous. It doesn't exist. So when I plug the 6 back in here, I'm going to get 2 times 6, which is 12, minus 1, which is 11. Log base 6 of 11. That's fine. They equal even, right? So they're going to ask you to state restrictions. So when you have logs, you actually have restrictions. Now why? You're going to see tomorrow because we have graphs of logs. The reason why you have restrictions is what's beside a log has to be greater than or equal to 0, right? I told you it can't be 0 and it can't be negative. So I just take what's beside the log. I say 2x minus 1 must be greater than or equal to 0. True statement? Whatever is in here, this 2x minus 1, it needs to be greater than or equal to 0. If it's 0 or negative, it's out. And then I just solve. What's the only catch with inequality signs compared to equality signs? When you solve an equality, you just solve it like normal, right? The only catch with an inequality is if you divide by a negative, what happens? Your sign flips. Am I going to divide by a negative here? No. So my sign will stay the same. So I'm going to add 1. 2x is greater than or equal to 1. Divide by 2. X is greater than or equal to a half. It didn't flip because I didn't divide by a negative. Is this solution greater than or equal to negative a half? Yeah, so it'll work. If the solution was like negative 2, I would say, 2 times negative 2 is negative 4 minus 1 is negative 5. Uh-oh. Can't have a negative beside. I would circle it, put a line through it, and say extraneous. But there isn't one here. So now if only it were true that I would give you log base 6 of something equals log that all the time. It would be so easy. You just take what's beside it, set them equal. It's not going to stay that way. So let's try one where it's a little bit harder. So solve. Log base 7, this one isn't going to be that intense. We'll do one that's a bit harder next. Plus log base 7 of 4 equals log base 7 of 12. So I know this still falls into type 2. Why does this fall into type 2? Yeah, they all start log base 7, log base 7, log base 7. There's not a term without it. Correct? Now, if I have log base 7 of something equals log base 7 of something, I can set the somethings equal. That's what we just did last one. Currently, I have log base 7 of x plus log base 7 of 4. Is that a single log? No. Do you know how to make it a single log? Yeah. Remember, when you have the same base, you can do what with them? Put them together, correct? We just did this rule. If they have the same base, you can put them together. So if this is plus 1, and this is plus 1, and this is base 7, and this is base 7, I can write it as log base 7, and what do I do with the x and the 4? 4x, multiply them. Remember, if they have plus ones in front, they go in the numerator and they get multiplied together. If they have minus one in front, they go to the denominator, correct? Yeah, you're just putting together as a single logarithm. So we're using that log. And now we're in the same boat as we were before, aren't we? Yep. We have log base 7 of something equals log base 7 of something. So I can say 4x equals 12. And then divide by 4, x equals 3. And then I can check it. I can plug it back in. Log base 7 of 3. That's fine. I also have one variable. The only variable I have is x. So if I go to state my restrictions, I'm going to go x is greater than or equal to what? What does it have to be if it's beside a log? Greater than or equal to what? 0. I'm done my restriction. I don't even have to solve for. This is a solving question, is it not? What I tell you you can do with every single solving question, doesn't matter what unit we're in. Y1, Y2, find out where they intersect, correct? Go, try it out. You're going to do Y1, the original. You're going to type this in, Y1. You're going to type this in, Y2. And hopefully you get x equals 3 as the intersection. Try it out. What if I give you this one? You're going to try it. So solve. Try this one out. I'm going to give you log base 7 of x plus log base 7 of x minus 1 equals log base 7 of 4x. Try and put them together. So we have log base 7, correct? We have plus ones in front of them, correct? When they are all logs, our goal is to get whatever's on the one side and whatever's on the other side into a single logarithm. Because if I have log base 7 of something equals log base 7 of something, I can set them equal. We agree? So I'm going to go log base 7. And now this has a plus 1 in front, and this has a plus 1 in front, so I'm going to get an x, and then I'm going to get it multiplied by x minus 1. And then it's going to equal log base 7 of 4x. Sadly, on the test, a ton of you will add those two. You don't add them when you put together single logarithms, right? You will multiply. Then we can FOIL that, or distribute, not FOIL. Log base 7 of x squared minus x equals log base 7 of 4x. So now I can say log base 7 of this equals log base 7 of this, correct? Can I not just say those are equal? So I go x squared minus x equals 4x. I can subtract my 4x over, so I get x squared minus 5x equals 0. I have two terms. Either I'm going to be able to factor it by difference of squares or GCF. What can I do here? GCF. I can take out an x. If I give you a trinomial, you guys will put it in quadratic formula. If I give you a trinomial, you'll factor it perfectly fine. If I give you this, which is the easiest one out of it, you'll stare at it for years, not knowing what to do. And it's literally just taking an x out. So I take out an x, and I'm left with x minus 5. And then I do two solutions. I get x equals 0 and x equals 5. Now remember, what did I tell you to do? You have to plug it back in and see if you get a negative or a 0 beside your log. Because if you do, that answer's out. And what we'll do on a test is I'll give you both answers, and you'll circle the one with both answers because you'll forget to check for extraneous roots and you'll be wrong. Okay? So let's check. I'm going to check 0 first. So I plug 0 in. I get log base 7 of 0. Am I allowed to have a 0 beside it? No? 0 minus 1 is negative. Well, it really fails there, and then again it fails there. It only needs to fail on one log. This one happens to fail on all of them. So that's even better. So what do? I circle it, and I put a line through it like that, and I say extraneous. Extraneous means, and some people will say, well, it means you should say no solution. No, it's not no solution. It means that was a solution. It's extraneous. It doesn't work. So I found a solution. It don't work. That's what extraneous means. Okay? Let's check the 5. Now, sometimes both solutions work. Sometimes neither of them work. Sometimes one of them works. You have to just check. Now, I can y1, y2 the original, correct? It won't show the extraneous roots. So sometimes on a test, they could just say determine the extraneous root, because I know you can't get it with your calculator, because it only shows the real roots. So let's check the 5. Log base 7 of 5. Can I have a 5 beside? Yep. What about 5 minus 1? That's a 4. Is that okay? Yep. What about 4 times 5? That's a 20. Is that okay? Yep. Done. So if I pick the multiple choice solution, it's going to be 5, not 0 and 5. Do you see how easy it is if you forget to check for extraneous? You're just so excited. You have both solutions. You circle it, you move on, and you're wrong. It's just the saddest day ever. Okay? You should catch your error, though, because you're going to, every single time it says solve, you're going to y1, y2, and check it with your calculator. And when you check it with your calculator, 0 will not come up. So if you're checking with your calculator every time it says solve, no matter what unit we're in, you will always catch the extraneous roots because they won't exist. Okay? All right. You try this one. So, log base 6 of x squared minus 24 minus log base 6 of x. Uh-oh, there's a minus sign. What am I going to have to do with these two? Divide when I put them together. You're going to try that one, and you're going to try this one. You gotta get the second step. So we get log base 6. On the top, we're going to get x squared minus 24. On the bottom, we're going to get x. And then on this side, we're going to get log base 6 of 5. And then, once again, log base 6 of this equals log base 6 of this. So I get x squared minus 24 over x equals 5. And what do I do when I have one fraction equals another fraction? Starts with a C, rhymes with Ross multiply. Ah, yes, cross multiply. Genius level. Big brains here. Okay, so we're going to multiply these bad boys, which is nothing. It just stays the same, and then these ones. So I'm going to get x squared minus 24 equals 5x. And what do I have to do whenever I have a squared in order to solve? This is drilled into your brains in hardcore format. Set, yeah, exactly. Set it equal to 0, and then factor or quadratic formula. Correct? Most of these will be factorable. Let's try this one out. So, we have x minus 8, x plus 3 equals 0. So we get x equals negative 8 and x equals negative 3. And then I need, that's a lie, 8. Okay, now I need to go and I need to try those numbers back into the original. That is not a word. Original. Okay? I put the 8 in. I'm like, 8 squared, 64 minus 24, 4. Good. Check. 8. Check. 5. Check. Yay! Okay, now I take my negative 3. I go negative 3 squared is 9 minus 24 is a poop. Negative 3. Nada. Look, everyone doing what I'm doing. Do what I do. I circled it. And then I put a line through it. And then I say extraneous. And then people don't believe me that that's what they all have to do in order for it to work out. But I don't do this for fun. It's not like that brings me great joy in my heart. You have to circle it, you put a line through it, and you say,
why don't you put a square around it?
You can put a square and put a line. I don't care. Okay, Talon? Go for it. Star, sure. It's really drawing people's eyes to it, though. Okay. Next one. We get log base 5. X minus 8 over x equals log base 5 of 7. Okay? Log base 5 of something equals log base 5 of something. And this one is a really nice one because it doesn't get you a quadratic. Yeah? So we get x minus 8 over x equals 7. I multiply, cross multiply, so I get an x up here. And I get x minus 8 equals 7x minus x. Negative 8 equals 6x divided by 6. X equals negative 4/3. And what do? Not give up.
No, that's actually true. It doesn't work.
Thank you.
What happens?
It doesn't work. So you have to give up. It's
You
negative.
don't give up.
What
What do you
Put a
do?
circle around it.
You
and
put,
cross it out.
yeah, and cross that, and you write
Extraneous.
extraneous. And then, in this case, and only this case, because there's no place where it crosses, we write no solution. Good thing that I dropped this a few too many times. If you look, that's what it's supposed to look like. That's what it looks like. It landed right on the.
At least you have your